So hello and welcome to this month's Digital Lunch and Learn. So please welcome Scott Roush, EE75, and South Dakota Mines President Jim Rankin, EE78, as they'll be discussing the new Avionics Minor here at Mines. And just some housekeeping things before we get started. This event will be recorded and will be uploaded to our YouTube channel afterwards. Some of you have already started, but if you can, in the chat function, everyone's always curious who's here. Just list your class and major just so we can make sure. And so without further ado, please welcome Scott Roush and President Rankin. Scott, you're muted.
Yeah, thanks, Sarah, for organizing this. And Jim, do you have to run, or do you want to make any comments first? And
I'm here the whole time, so I'll let you lead.
Okay. Yeah, just chime in if you want to add something as we go along. Sarah, I'm going to try to share my screen here. Okay, Sarah, can you see that chart?
Yep, you're good.
Okay, I'll start off with a few comments about the EE department here. We've had some changes. We've had some changes in the last 4 or 5 years regarding the components of our department. We used to have computer engineering within our department here. And that has been recently, well, in the last 4 years or so, moved over to the computer science department. So we always get some questions about what is the differentiation between these various departments that are closely related. And this is kind of our standard answer here for EE. We have hardware focus and some programming. Computer engineering is more of a mix of hardware and software design with a bit of programming. And then computer science is almost 100% programming. So as far as the avionics courses and the avionics minor goes, we're going to get most of our students out of these two, and then we're also going to get several out of mechanical engineering. Mechanical engineering, they started up an aerospace engineering minor at the same time we started our avionics minor. And so they've just got 1 semester under their belt like we do and launching into their 2nd semester now. So they're going to be mostly structures, propulsion, that side of the business, and we're going to be more of the electronics and systems over here. A bit more about our department here. We've got currently essentially 140 undergrads and 19 graduate students. We continue to get good marks from the groups, the organizations that rate EE departments. So we're consistently in the top tier, and these are a lot of these have to do with return on investment. We're perceived as a school that turns out good engineers and at lower cost. Right now, we're sitting at 70%, 77% of our undergrads get interns or co-ops. And we have at graduation essentially 100% placement for our EEs. Good starting salaries. I think the last average was 72.8K. And we just had a career fair with 119 companies here. 63 were looking for EEs, and then we have another. This one was from last spring, but we have another virtual career fair coming up here shortly in February. So we've got good demand for our graduates coming out of the department here. These are some of the companies that have hired our seniors in avionics. Raven Industries, they recently are, well, they've split the company into Raven Aerostar, and then they have a films division and then a precision ag division. And so their company has just been purchased here the last 5-6 months. And we're not sure exactly how that's all going to play out. But Raven has been a big supporter of our department and has, I worked with them in the Aerostar division to help set up this Avionics Minor. Garmin hires a lot of our students down in Kansas City, and they were some of the folks we know down there also helped me set up the curriculum and the course content for our avionics courses. L3 Harris has been a very good friend of ours here in the department. They've donated a lot of equipment, and they hire a lot of our students. Collins Aerospace, they've got a lot of our graduates there at Collins, and I spent about, I suppose half of my career at Collins and the other half here at Honeywell in their aviation division, avionics division. Raytheon, Boeing, Northrop Grumman, Lockheed Martin, we've got a lot of graduates at those places, and I put Blue Origin down here because the student who worked with us to get our flight simulator set up ended up going to work for Blue Origin. So he's done really well in his career. Here's in EE, here's our areas of study. So these are courses and projects you could work on in these fields. Of course, our aerospace and avionics, communications, power, electronics, embedded systems, controls, microwave antennas. And then because we're a small organization here, if a student has interest in some particular field, we can always set up a special project, especially a capstone senior design project that help them get going on a track that they're interested in. Here's our research areas. So we've got grad students working in these areas. Kind of a subset of the previous chart. And then I thought I would spend a few minutes on our senior electives and our junior classes, since some of you listening today are EEs, and you've been here a few years ago, and so this is kind of where we stand today. So the senior electives are just like they've been in prior years. You need to have 12 credits, 3 courses of senior electives. And these are our focus areas here: power, communications, controls, embedded systems, and then this latest one, systems engineering, and that's where our avionics program fits. So what we recommend to our students as soon as they come in as freshmen or at least sophomores, after they've kind of got their feet on the ground, we introduce them to these focus areas. And then when they get to be seniors, we suggest courses that they can take to get more depth in their each one of these focus areas. We suggest 2 depth courses and 1 breadth course because we know that you just never know where you're going to end up in your first job. So we try to cover, get them prepared in an area they're interested in, and then with a little wiggle room in case they get an offer in another business or another company. The embedded systems, I'll just comment on here. So this is, if you're a EE and you want to work with computers or embedded systems, we suggest these courses, and these are taken over in the computer science and computer engineering department. But you can still get a EE degree that has an embedded systems focus, and that's still a very powerful focus area in the job market. Let's see, just a comment, I guess, on our junior courses. A lot of these have been stable for many years. The Signals and Systems course, controls, electromagnetics, robotics, 362 electronic and magnetic properties of materials. We do probability and statistics is one of the required junior classes, Electronics 1 and 2, and then an energy systems course, which talks about transformers, motors, and generators. So this gives a student who is going to be maybe in embedded systems, gives them a little motor experience for smaller projects, but then this kind of the introductory course into the utility and the utility energy business. Okay, our Avionics Minor is new as of this last fall, and our graduating seniors qualify for that minor if they take one more course. So instead of one more senior elective, so instead of the 12 hours, they take 16 hours of senior electives, and then one of those courses is the Avionics 1 or Avionics 2. So normally these students will be sticking around, they'll graduate and then they'll be sticking around here for working on maybe a master's degree or accelerated master's degree. This philosophy of one extra course is commonly done here in the other departments also. So when we started thinking about this seriously, Dr. Rankin can make a few comments here at the end. He and our provost, Lance, were the key guys to get this going. I mean, we've been thinking about this for quite a few years, but Jim and Lance's communication with primarily Raven over in Sioux Falls really is what got this program off the ground and brought it to reality. Our courses here are to prepare students for a career in an aerospace company. I worked with Raven, Aerostar, and Garmin to kind of put the program together here for avionics. We anticipate and we're seeing that EEs, computer engineers, and MEs are the ones that are most likely to sign up for this avionics these avionics courses and the Avionics Minor. We have a very excellent facility, which I'll talk about later in the presentation. We have a flight simulator here in our department that we started building in 2015. The guy that I mentioned who went to Blue Origin, that was his senior design project. And so after we set that thing up, every year we've been building on it and adding some follow-on projects to get more usage out of that equipment. And we're very flexible there. If a student has some project they want to do for a senior project, we're happy to work with them to get that integrated into the flight simulator. And that makes really good material to talk about on a job interview or on your resume. Before we started the avionics courses, we generally put about 3 or 4 SINGs, computer engineers, and EEs into avionics every year anyway. So our hope is, and our plan is that this avionics program will get more students into this field, into this business. Of course, when we talk to these companies, we love to have them look under their stairways and in the lab and dusty equipment that they might want to donate to us. And it may be a liability to them, but it certainly is good for us to give the students some actual avionics gear to work on, and we can then integrate that into the flight simulator. So get into a little bit of the coursework now. These are the various segments, business segments of commercial aviation, air transport, computer and regional, business jets, general aviation, and business aviation helicopters / rotary wing. So my career, I spent in this area mostly, but about a fourth or so, up to half in these areas. I was before I retired, I was an airplane owner, so I had a Grumman Tiger and flew that all over the country. And it was a very good experience that helped me, since I was working in this area, helped me kind of get involved and get some practical experience that I think helped when we designed this for a real customer. So that's commercial side. We also have a lot, military also has a lot of aviation, transport category, strategic, tactical, rotary wing, drones, and ground-based systems here. So we've sent graduates into all these areas, and they're all very, very excellent and exciting areas to work. Because Raven Aerostar is in this business, I put this in our program. They wanted the students that they hire to have a little bit of background in space systems. So this consists of satellites, missiles, and radars. Raven is big into radars, some comm systems, a lot of controls, and then the films and lighter than air systems are what Raven is interested in also. I think it's a surprise to most of our EE students that when they graduate, you know, they consider themselves or they envision themselves sitting at a desk, designing some circuits, maybe testing something out in the lab. And so it's a surprise to them that when you go into our avionics business, you can land about anywhere. So yes, you can do electrical design, but us EEs are very capable of doing simple mechanical designs too, and we do that a lot. Systems engineering, once you start taking a more holistic view of the airplane and the systems, flight dynamics, and my window is setting over some of the stuff over here, which I can't see, but software engineering, of course, manufacturing, safety, test engineering, sales and marketing, simulation. All of these functions are done in the kinds of companies that we want to market our students to. And of course, most of our students will be in project management within 3 or 4 years. They'll be in first line supervisory positions 5 to 7 years. And commonly we'll get to department head, director, and VP and CEO levels later on in their careers. So what we try to do in our senior design courses is give them some budget experience, scheduling, project management experience that they can use to climb up the management ladder if they so choose. The kinds of things we talk about in our avionics classes, we use the flight deck or the cockpit systems kind of as the portal to look into all of the various systems in the aircraft. So this is a 5767 Boeing flight deck. This is a simulated military system, and I just pulled some of these off the internet just as examples. And then here's a general aviation helicopter. So the kinds of things that it takes to mechanize these aircraft and get them going and control them are the things we talk about in our avionics class. Here's a picture of kind of a late 60s, early 70s of 727. And in the old days, this was a 3-person cockpit, 3-person flight deck, and they had a pilot and a co-pilot, And then they had a first officer who sat back here and managed all of the other systems on the airplane, like the passenger entertainment and all the maintenance systems. And so you can see there's a lot going on in one of these commercial airliners. And because of technology, memory, processing, the trend in the business is to simplify and to integrate functions into smaller and smaller packages. So the 5.7 and 6.7 and 3.7 also was the first Boeing airplane to get rid of this first officer and go to a two-person crew. And so we talk a lot about in our classes the use of technology to get more integration in these aircraft, to accomplish more things or cut costs, more capabilities, more safety. That's the name of that tune these days. So our courses, and I'll tell you more about the course content here in a bit, but we tend to look at the flight deck, or the instruments that the pilot looks at when they're flying the airplane. And so this is a 5.7, 6.7 display. So along here we have airspeed and all the various things that help the pilot manage airspeed. Over here is the altimeter. Over here is vertical speed. Down here is the navigation display, the compass, and the lateral course and heading settings. Right here in the middle is pitch and roll. And then up here is the various modes that the autopilot is in to fly the airplane. So in our Avionics One class, we broke the class down into the various systems that sense this airspeed, altitude, et cetera, sense that data, process it, and then present it to the pilot and co-pilot for use when flying. That was the primary flight display. This is the navigation display. So this shows the heading and course, all the waypoints, airports, and this display helps them make a flight plan and manage their flight from point A to point B. All the modern new systems have some sort of a center display or a maintenance engine display. So what this one is, it's a combination of engine parameters, well, including this, a little bit of passenger system. So here's the cabin data, cabin altitude, pressures. This is the auxiliary power unit, landing gear status, a simple display of pitch and roll. And then these displays here have to do with the engine parameters. So we do have a module in our course about modern turbine jet engines and the various parameters that you need to read and process in order to control a high performance jet engine. This is an example that I show the students about what the stuff they design, what it looks like in a physical airplane. So it's the typical black box that you hear about on the TV. So this one, I'm not sure what this one is for. It's a Collins box. But there's a rack in the airplane that just is populated with, you know, a dozen or a couple dozen of these kinds of boxes. So the computer that you design or the I/O module that you design is a circuit card that fits in a box that looks like this. Okay, we'll look at some of the details of the course here. Oops. So this is a one-page description of our Avionics One course. So we have two Avionics courses, and we do the Avionics One in the fall, Avionics Two in the spring. So we just got these approved by the Board of Regents here just a week or so before the fall semester started. So we'd been thinking about this for a while, and but it, you know, when it's time to actually get going, you know, we kind of scrambled at the end to get the thing actually going. So these are senior electives, so they're 3 lecture hours plus 1 lab hour. Because this is a new endeavor for these students and for us, I didn't want to specify a textbook that they had to spend $250 for when they may or may not be going into this as a career. So I spent quite a bit of time finding free versions of the popular textbooks online that we could download and use for free. And that saved the students a lot of money. Plus, we could pick and choose the best parts out of the textbooks that we felt would be appropriate for this class. These are all famous people. If you're in this business, you know, Carrie Spitzer is a very famous guy, passed away recently. This is a very famous person. Of course, Al Helfrich is very famous in our business. Jim has worked, I know, with Al Helfrich in his past life, and I have been on committees with both of those guys. I didn't know this guy though. Also, we pull a lot of supplemental data off the. I buy the supplemental data here, and it's 737, which is one of the aircraft that we use in our simulator. So we've got a 737 pilot's handbook. And then for simplicity, we use a twin engine Beech Baron general aviation airplane for just learning and getting familiar with the system. I divided this course up into these various modules. So the first module here, so each one of these is you know, a couple weeks long. And so we talk about the major companies, the FAA, the business models of our various segments, a little bit about the standard atmosphere, the regulatory environment, and air traffic control, which kind of hooks all of our systems together. So you can imagine each one of these you could spend your whole career doing. We cover them in a couple weeks. So the content is a bit abbreviated, but it's enough, I think, to give the students an appreciation that what they're going to be doing is part of a larger picture that's very highly regulated by the FAA. And there's a lot of things that have to happen. And so coordination with other companies, being compatible with other systems, that's all part of module 1 here. And then in module 2, we go into the details of the subsystems since my background is in commercial, these are things that would be typical of an air transport airliner or a business jet. So the cockpit systems that the pilot and co-pilot use, the various digital buses in the aircraft that tie this together. I have a few homework problems on the ARINC 429. It's commercially, it's used everywhere in the air transport world. Some of the documents are available for free. So I was able to get some homework assignments put together using these digital buses. Power systems, we used let's say, I think it was a Canadair something or other that we used as an example for the AC and DC power systems in a typical aircraft, and then how that power system is managed. What happens when you have a generator failure? How are failures of the power system handled in the avionics? And then the air data and attitude system. This gives us the airspeed, altitude, pitch and roll, heading kind of data. So through module 2, now we're getting into the details of the systems in the airplane. We have a module just on navigation, and that's huge. So that talks about GPS, instrument landing system, the VORs, ADF, the basic beacon systems that we have, and talk a little bit about, well, a lot actually, about long-range navigation. Let's see, then we have a module on comm systems, and then on pulse and surveillance. And so those are radars, collision avoidance, those kinds of systems. Then we have a major module on autopilots, what they use in what they learned in their controls classes, how that actually gets implemented in control laws in an autopilot. Flight management is huge. We talk just the basics of what a flight management system is, and then the basic functions that it provides. Maintenance and warning, engine control. I got a module on, or a couple of lectures on weapons management, and then drones and autonomous flight. We at the School of Mines, we are known, I guess, for practical, hands-on kind of stuff. And so I worked real hard to get some what I think are decent labs to be in this, to put in this course. One thing about this Avionics Minor and this aviation systems course content that we're doing, one of the, it's not a problem, but it's something that I try to keep in mind all the time, that if you're very seldom going to be hired into a systems group as a entry-level engineer. You're going to be into the hardware group, you're going to be in the antenna group, maybe the cockpit instrument group, and you're going to be a hardware or software person mostly. So what I try to keep in mind is that the personnel recs in these that these companies write that authorize them to come out and hire people, you know, they're not going to have aviation systems as one of the bullets on that personnel rec. You know, they're going to have hardware, software design, whatever. So what I try real hard to do is in my laboratory content here, have practical content that the students can write down that will catch the eye of somebody that's looking for a hardware person or a software person. So one of my first labs here is a flight simulator familiarization. So I encourage these students to come in in the evening or whenever to fly the simulator. So I don't have a key on it. I don't have police tape around it or doors locked. I want the students to come in and use this stuff that's been donated to us. Then I had a lab on phase lock loops. So that's used all in radio tuning primarily. They learn a lot about controls in their controls class. And so lab 3 was taking something they learned previously in state space and then converting that into a control law, changing the transient response or the lag or whatever parameters you might be interested in, how you can make changes in the state space parameters to accomplish what you want to accomplish in the autopilot. First order analog and digital lag filters. These are pretty simple, but the students, I think, are always surprised of what you can do with just these simple first order systems. One of the things that they'll work on a lot, especially if they're a hardware person or a systems person, is thermal management. So I have a nice lab in there on how to get heat out of components and get it off through a heat sink or fixturing or some method to get the heat out of an electronic circuit board. And then, so as I got this far, this was the first course and killed me to get this much done this year. Kalman filter is something that's used all the time in navigation. So I put together some Kalman filter examples, and just to give the students some experience with them, what the term means, how you can implement them in a simple way. And I've had a couple of them now come back and tell me that that Kalman filter, that phrase on their resume, is what got them their job interview. Next semester, or next time we have the class, I'm going to add some more here. Where I'm always looking for ways to add content and facilities on our flight simulator. So that was Avionics One course. Avionics Two, which we're doing for the first time right now, is, okay, how do you make money in this business? How do you get something certified and get it approved by the FAA and have it available to sell to a customer? And so, again, we talk a little bit about the certification process, talk about the importance of requirements and testing. We use an automated tool that we and the systems engineering people here use to capture requirements in a big database and then link them and have a traceability to test procedures to validate the requirements that you've set up. We're just now finishing, tomorrow, we'll be finishing this module 2. So that's talking about reliability and safety and redundancy and where all those requirements come from in a commercial airliner. And fault trees is a big part of this. Okay, the next 3 modules we're going to have in this class is a hardware development process. So this is a standardized hardware development process that engineers will use to put together a hardware design that is known, that works, and can be certified. That's relatively new in the industry, say within the last 10, 15 years. We've probably for the last 30 years, we've had, or 40 years even, we've had this DO-178 software process. So that was the first one that actually got regulated so that reliable software, and I'm doing air quotes here, which you can't see, I'm doing air quotes with my fingers, high quality software, what that means and how you produce it. Then for the hardware folks, environmental qualification, that's the vibration, temperature testing, and there's 20 or so different kinds of tests that you have to pass to get certified on a commercial airliner. And then here's all the labs we're going to be doing this semester. So that's our Avionics 2 content. Okay, we had Avionics 1 finished up last semester, first time for the class. I had 23 students in there. And this is how, so now we ended Avionics 1, started Avionics 2 class. Where did the 23 go? Well, 9 of them continued on in Avionics 2. Of those 9, 4 are still evaluating their jobs. I mean, they've got interview trips and they're in the process of looking. They may or may not end up in an avionics company. 3 in the class have actually been hired already. And when they graduate here in May, they'll be off into their avionics job. One of them was hired by a company not in avionics, but he really wants to be in avionics. So he's got an offer, but he's looking for 2, he's got 2 more possibilities in avionics that he's pursuing. I believe that he is going to get one of those jobs and then he will transition into my hired in avionics. And then I have a very interesting person, a friend of the department, a retired pilot and a flight simulator enthusiast. He joined my class last semester, and he's in with me again. And together we can come up with a lot of stories about flying and the fun that we can have in this business. So, and then 3 of the 23 graduated in December, this last December. None of them actually were hired in avionics. I think most of them had their jobs lined up before they took my class. And all 3 went into areas not in avionics. I've got 11 of the 23 are going to graduate here in May. 4 of them have got job offers and they've accepted in avionics, and 7 are in other non-avionics kinds of companies. So we've been, I said a few charts ago that we usually have 3 or 4 that go in this business every year. It looks like we're going to be at least double that already, sending kids into this business. And we have an opportunity for a few more here before May gets here. Okay, so here's a little bit about our hardware. I think this makes our department unique, maybe in the nation. This capability that we have here, our flight simulator. Ben was a Air Force guy, and he ended his Air Force career, or his enlistment period. He was a maintenance tech out here at Ellsworth. He came to the School of Mines, finished up his bachelor's degree, and was interested in this kind of stuff. So I latched onto him to put together our flight simulator here. So this thing has 2 computers. It's a 737 partial flight deck. A very nice throttle quadrant, nice control yoke, nice rudder pedals down at the bottom here. So that was our basic system. And it can do a primary flight display here, a navigation display, and a engine and multifunction display. So not only does it have the instruments, but it has we've got one of the video outputs hooked up to our overhead projector in the hallway here where we have this system. So we have out the window graphics that are very good as you're flying around, as you're flying. You can I always run this thing in the minimal graphics mode, because so then most of the CPU horsepower can be done with the avionics calculations rather than the graphics calculations. But you can put this simulator in 3 different graphics levels. A basic one like this, kind of a medium one, and then one that would look just like if you're flying over the actual ground. We can take off and land any airport on Earth. It can do winds aloft simulations, turbulence simulations. I can fail different pieces of equipment and do a flight scenario, a pretty interesting flight scenario. Then here's where I'm really most proud of this part of it, actually. So the seniors come along, it's time to do a senior design project. Okay, I like airplanes, and maybe I'd like to be in this business. What should I do? That's, I guess I have that conversation every semester with 5 or 6 kids. And so I talk to them a bit and say, okay, what we talk about are you a controls person? Are you interested in communication or antennas? And based on what they tell me while waving their arms, we'll put together a project. So this was the very first one we did. It was this guy was interested in controls. So we put together this auto throttle system. So it has an Arduino, it has a bunch of power electronics. We cannibalized this motor off of an old wheelchair. And here we 3D printed this control lever here. And so what we did with this project is we hook up to the simulator. We get the digital values out of the simulator that come into the Arduino here that say, okay, I need this much thrust to fly whatever scenario I'm trying to fly. And then what we do is calculate the position of the power lever here to give us that much thrust. Okay, so that was a very nice first project. What time is it? Okay, I'll speed this up a bit. Autopilot control panel. So this lashes up to the autopilot function in the simulator. So it's got hardware design, software design. It's got an Arduino in there, a LCD display, and this lets us select a vertical and a lateral navigation mode. So we can select one that can be our armed, and then once those conditions get met, that the autopilot will actually connect up and fly to that. And then once you have that, you can select a second armed mode. And that's all done here with this control panel. This guy got the exact job he wanted and the exact square mile that he wanted to live in. So this project turned out really good. This is 3D virtual reality. So we had some students interested in that. So this is a set of goggles. So you're flying in the simulator, you look down and you can see the earth below you going by through in the goggles here. We also did a project similar to this with Union Pacific Railroad for training purposes to help them mechanize or train people on how to run all the controls in the front of a locomotive. Here's weather radar. We can't be turning on these high power radar beams in our lab. So I mostly use this Collins weather radar antenna for the computer engineers to hook up to sweep the thing back and forth, up and down. And then when we change pitch, the antenna position tracks the horizon or wherever you want to follow simulated clouds. That was donated by Collins. Here's another one that we're real happy with. Here's another radar project. I know a couple of people were here over the summer and from Raytheon, and they're doing guided missiles and that kind of stuff. So I said, gee, what would be an interesting project? So they came up and looked at the simulator. And so here is a project using two small radar units. And they're at 3 to 5 gigahertz. And what this sets up in the front of the flight simulator. And what we do is when students walk through the hallway here, it can track up to 8 students walking in the hallway. On the flight simulator, then you can move a mouse and select one of those targets and hit fire. And then we built a little Nerf gun here that will shoot Nerf balls at the target. This was a 3-person project. All 3 of them got hired at Raytheon. Here's an engine system. This is on the overhead panel. So what we put left engine, right engine, and an auxiliary power unit. So using single phase AC motors, driving modified car alternators, which generate 3-phase power, which is what you have in an airplane. And then up here on the overhead panel, you can program how you want the redundancy. So you can fail the left engine. Okay, how should we get power from the other 2 sources, the other engine, the APU? So that's all programmed in here. Of course, both of those guys got jobs doing this. I've had 2 different projects now with collision avoidance. The first one was just getting a commercial system up and running. And then this last semester, we just finished this one. Garmin gave us some equipment and we integrated that into the flight simulator. This I didn't have any pictures for, but we have a drone swarm that flies a pattern over by our wind turbine. And that comes over on a data link at 2.4 gigahertz to the flight simulator. And then we can plot all those drone targets on the flight simulator nav display. Of course, that's one of the big issues in aviation right now is how can you fly around without hitting all these drones that are also flying around. Let's see, a couple other things they're kind of fun. I'll close out here with this one. So I got a call one day or an email from a high school math instructor over at Douglas High School here. And he had a student that wanted to work with airplanes. And so could I don't know if you can see this down at the bottom here. So he said, can you put together a project with math? Okay, so I said, sure. And so what I did is gave this kid came in, I think we went for 6 weeks, one night a week. And so we put together a flight plan from Rapid City to Gillette. So take off, land in Gillette, take off at Gillette, come back to Rapid City with a known crosswind. And so those of you who are pilots, you'll know that with a crosswind, there's quite a bit of trigonometry that you need to plan your flight from here to here and back. So we did that, and we were off by only 2 minutes for the whole duration of our flight. So that was pretty good. Okay, we'll close out there. These are some of the improvements that we're going to be making in our lab here. We got a nice grant from Raven here this year or in last fall. And so we're going to upgrade our high-speed, our hardware design facility to include more high-speed work, update substantially our surface mount prototyping. Going to put in several enhancements on the flight simulator and get some environmental qualification lab facilities set up. Okay, Sarah, Jim, if you've got something else you want to add, and then I'll turn it over to you, Sarah.
Tell you what, I'll go ahead and just talk briefly, and then Scott, there's a comment or two in there that you might want to take a look at it. But I was just going to say, you know, I graduated EE in '78, and when I started at Rockwell Collins, there were 11 of us out of the EE class. I think a third of our class went to Rockwell Collins that year because that's when that 7.5, 7.6, program was just getting started. So a lot of us went into that particular field. That's, you know, knew Scott down there as well. But I was just going to say, you know, Raven's been a big supporter of both the aerospace engineering program as well as the avionics program. And they had a couple things, you know, obviously avionics is very important to what they're doing, and they wanted to make sure they had a good supply of talent sticking around in the area. But they also wanted to make sure that students graduating from South Dakota high schools had a place in South Dakota where they could go get a degree in avionics and aerospace because they thought there'd be a lot of interest in that. So both those reasons were pretty good. And really, you know, we jumped on it. Actually, it was Dr. Roberts and I standing next to an elevator with the Raven CEO, and a comment was made by one of our alums that they were interested in aerospace. And so we were happy to jump into that field and keep moving. The other thing that I think is interesting when we talk to the folks at Raven, you know, their new acquisition, or the acquisition, is based on agriculture. And as we explained that, you know, avionics stands for aviation electronics, but these same things could be applied to agriculture and precision ag with autonomous operations and databases and communications and navigation. We're seeing the same thing in the mining engineering with autonomous operation of our mines, and, you know, as we see driving cars. So what Scott and the group are teaching in avionics apply in a lot of other disciplines. So that's great to see. And we're hoping we'll see more interest in Rapid City as the B-21 moves into Ellsworth Air Force Base, and those contractor companies start locating engineers and wanting to hire engineers to be local. So a lot of exciting things going on in this area, and Scott's been doing a great job with that. And I don't want to take any more time, but when you want to come talk to me about my latest research, it's on flying cars and how we put ADS-B with it. So I will save that for later questions, but great job, Scott.
Yeah, thanks, Jim.
Yes, thank you, Scott. Scott, we did have a question come in that says, is the school's flight simulator approved by the FFA for training per 14 CFR Part 61.4C? This would allow students to work towards a private pilot certificate while in school.
Yeah, the answer is no, but it could be. We use X-Plane 10, and if we had, I'm doing air quotes here, if we had some configuration management on our system so that it wouldn't change all the time, and every time a student comes in and does a new project, they doctor the parameters. So I've thought a lot about that, and I've kind of decided just for what we're doing here in engineering, I think I'm going to stay with just letting the students do their thing and not have it be certified for logging hours in flight training.
Thank you. Robert Allen asked, are these slides, can you get the slides to me and then I can send them out to people who want them?
Sure.
Okay.
Sure.
Robert, if you want the slides, I can get them for you. I know we're coming up on top of the hour. Does anyone have any questions or anything for Scott? Oh, looks like another comment. How do these course offerings compare with North Dakota State University?
I looked at at North Dakota State, and there's a few other places around the country that do these kinds of courses, and mostly they're in programs that are in their aerospace engineering. So what the North Dakota State people do, they're focused on a lot of flight training and getting a pilot's license, and we're not going to be doing that, at least initially here. Most of my work is going to be on the hardware and the software design to try to integrate with real avionics equipment into my simulator and give them some some hardware and software experience when they go out and look for a job. And I mentioned before about the fact that when these companies open up job recs to hire our kids, you know, they're very entry level, right? So and mostly in the avionics companies, when you get into the systems group, that means that you've been there 15, 20 years and you're kind of an expert in all things airplane. And so it's not reasonable to expect a person just out of a BS degree to have that detailed knowledge. So I want to make sure that we have enough practical stuff that matches up with the job rec that they're actually going to see when they go and interview. And then with the general knowledge that we have here, that can position the students to get promoted into a systems group or into management faster. That was a long-winded answer, but sorry.
I have a question. If anyone else has any questions, please feel free to put them in the chat or the Q&A. I'll watch for them. If alumni wanted to get involved in the Avionics Minor or just with what you're doing in general, what would be the best way, or what are some things that they could do? Or is that a possibility?
Yeah, if you're an alumni that works in a aerospace company and you have some equipment that you'd like to donate, we would love to have it. Things like radio tuning modules, Autopilot computers, just anything, especially if it has a digital bus. And if you're with the company and if you can give us documentation on that, that would really help us. So we're always looking for things that are actual avionics hardware that the students can get some experience with and then write about that on their resume. That's very powerful.
Thank you, Scott.
And of course, cash donation always works too.
Oh, we also appreciate knowing about internships and about our positions. So anything you can add that way, but come visit us.
Yes, come visit and try the flight simulator.
Yeah, it's a regular stop on our department tour, so.
Scott, I don't know if you saw, but Scott, Robert Allen said, I think when you were talking about the different types of avionic courses, I think these 2 avionic courses will go a long way to preparing students for a career in the aviation industry. My group has been hiring the last few months, and it's really difficult to find people with any knowledge in the areas you're covering.
Oh, okay.
Share that feedback with you, so.
Okay, cool.
Yeah. Okay, well, we're getting to top of the hour. If anyone has any questions or anything, you can feel free to email Dr. Rankin or Scott. They'd be happy to answer any questions that you have. And then I'm going to drop a couple events that we have coming up. I always like to push for them. Next week, we are doing a trivia night, Wednesday, February 23rd at 6 p.m. It's over Zoom. And then the next, wow, it's April already, March already. It's going by fast. The next digital department update we'll do is from chemistry, biology, and health sciences. So I'll put that information if you're interested in checking out more or being a part of a trivia team. So thank you, everyone.
Thanks, Sarah.
You're welcome. Thank you, Scott. Thank you, Dr. Rankin. I really appreciate it.